Okay, so under the Chapter 1 notes, where there were mice that were studied for liver tumor under E. coli versus liver tumor in a germ-free setting, I want to help us analyze a two-way table, just like one that was in your notes. So you can do a Google search for Rossmann-Chance, and this pops up, rossmannchance.com applets. We're going to go to the Analyzing Two-Way Tables. So if you click that, we're going to pick sample data 2 by 2. And the success was E. coli, liver tumor with E. coli was 8. And for the germ-free with liver tumor, it was 19. For no liver tumor with E. coli, it was 5. And for no liver tumor germ-free, it was 30. So we can click Use Table, and you can see there's the table. This is successes versus failures. And we can click here, Show Table as well. This is the same table that you have in your notes with the expected proportions that we had already devised. This is the difference in successes of 0.615 minus 0.388. So again, as you see in the notes, the question is this difference of approximately 62% to 39% significantly different, or is this difference due to random chance? You could look at this difference in proportions, but we're going to focus on cell 1 count. What that essentially does is it asks us to look at the entire table, the marginal totals for rows and columns, with respect only to cell 1, which is the success, which in our case is getting a liver tumor under E. coli. We're going to do a simulation because we've only got one experiment here, but if we simulate, we could show what would happen if we had done thousands of experiments under the randomization. So, and just like it mentions in your notes, we could simulate with a deck of cards, but it's much better if, especially if we want to do 1,000, if we simulate it with a computer. So we're going to type in number of shuffles is 1,000. We're going to click shuffle, and you can see that there's the distribution of the counts. Now these are the counts for quote-unquote success, which in our case is having a liver tumor while under the E. coli. And so what we want to do is we want to look at the count samples. We are looking at what is the chance that it would actually have been greater than 8. So if we put in 8 and then do the count, you can see that in this case it says that it's approximately 12.5% chance. And while 12.5 is not that large of a percentage, statistically speaking, that is not significant or an extremely important event. So more than likely, because we've done this as 1,000 times and we've never found any sort of significance, we would say that more likely the effect of getting a liver tumor due to E. coli versus germ-free is more likely due to random chance. If you're not sure, you can always shuffle again. Notice that the proportion changes again. So each time you shuffle, you're creating another randomization distribution. There are many more things you can do here. Eventually in this class, we'll be talking about confidence intervals, and we will do more with difference in proportions. We will also be looking at relative risk and chi-square. So all of these will be available later, but for now, that's enough.